Given the following reactions below, this is Hess's law. Calculate the enthalpy for the reaction. So basically, Hess's law just involves you being able to reverse the equations. Um, so in the way that you should be able to produce the final equation itself. Okay. So I think it's under chemical kinetics where we learn about what we call the reaction mechanisms. You understand that actually a reaction doesn't just happen. There are steps that are involved for that reaction to actually happen. Okay, so this is what we're seeing there, and each of them have got their own enthalpy, as we can see. Now, looking at their energies there should be able to help us determine the enthalpy for the overall reaction. Okay, so to make our things easy here, we should compare each single step against the final equation. If there is something that is appearing on the opposite side, we should reverse the equation, and if we do reverse, the enthalpy should change the sign. Okay, in a case where we multiply by a 2, that should also be multiplied by a 2. Okay, so let's try to now observe, starting with the first equation there. If you look at the first equation, we've got ethene there, we've got oxygen, we've got carbon dioxide, we've got water. Now, if you look at our final equation, what is existing in that equation and this one? Are you able to identify them? Okay, so I can see ethene is present in both, and they are both appearing on the reactant side. Anything else? Okay, just that. So we only have ethene present in that equation. Already that should give you a hint to say, well, if it's only ethene that's present, then these others should be eliminated along, okay, our process. So there's no need of us to reverse because they are on the same side. Okay, so that equation should remain as it is. Okay, so done with the first one. The second one, I can see ethane there, I can see oxygen there, I can see carbon dioxide, I can see water there. Anything that is appearing in this equation that you can see? I personally can see something. Okay, so ethane, this one there, is actually appearing, except it's on opposite sides. So what should we do? So we should reverse it. So the products will become the reactant. So we're going to have 2 carbon dioxide plus 3 water molecules, okay, giving us the reactants will now become the product C2H6 plus 7/2 of oxygen. Okay, so I've actually used too much space there. My writing has been poorly done. Let me reduce some sizes. Okay, so let's move this a little bit. So we have C2H6 plus 7/2 of oxygen. So the enthalpy will now change the sign because we've reversed it. So 1560 kilojoules per mole. So this one has been changed. Let's do this. Now we can move to the next one. Compare it against the final equation as well. What we have. So we've got hydrogen present. We've got oxygen, we've got water. Anything that is appearing in the final equation that you can see? Well, I can see hydrogen is common. Are they on opposite sides? They're on the same side of the reactant, so we shouldn't reverse that one. Okay. So the other 2 equations have remained as they are, and then we've only reversed one. Let's see. Is this able to cancel all that is unwanted and give us that as a final equation? Let's try to cancel out what's appearing on opposite sides. So can start with the first one. Let's try to observe these three equations. Maybe I can actually even just write them down. Let me get them. So I've got C2H4 for the first one plus 3 oxygen moles plus 2 carbon dioxide plus 2 water molecules. The enthalpy is negative 1411. Now for the third one, we've got hydrogen, we've got half oxygen, we've got water. The enthalpy is negative 285.8. Okay. What's appearing on opposite sides? Okay, I can see this. Carbon dioxide and 2 carbon dioxide can cancel out. What else? Those 2 water molecules can cancel out with these 3. So remain with a single one there. Since there were 3, we've cancelled 2. And then this can also cancel with the water molecules there. So the water molecules are eliminated completely. Anything else on opposite sides that you can see? I think oxygen. Where is the oxygen? We've got 3 there. We've got 7/2 there. So 7/2 and the half can also cancel out, first of all. Now if you cancel out of 7/2, remove half of the oxygen molecules, you're going to get 6/2, which is actually just 3. Okay? So if you cancel the half, and then there you cancel, you remain with 3 of the oxygen molecules there. Now that 3 can cancel with the ones on top. Anything else that's appearing on the opposite sides? I can't see anything else. What has remained? On the reactants, we've got ethene and hydrogen. So you can write them C2H4 reacting with hydrogen. Then on the product side, this one is completely eliminated. For the second one, there is ethane there. Anything else here? There is just water, which has already been cancelled. So we can see that this is actually matching up with what? Our final equation there. Then we are confident that we can actually now add up what we have on the right. So we've got negative 1111 plus 1560 minus 285.8. So we only reversed one of them, which meant we only changed the sign of the middle one. Okay, so what are we getting as our final answer? I'm getting negative 136.8 kilojoules. Okay, so if you want some more practice on Hess's law, go to the topic thermodynamics. The link is in the description below if you're on YouTube. If you're on our site, just go to thermochemistry. You'll be able to find the video on Hess's law for more practice.